Good afternoon. My name is Angelo Hernandez, and today, as part of the term project for the coastal system analysis, I will present the sea level rise and storm surge effects in Tampa Bay's area critical infrastructure. So this will be the agenda for today's presentation. So I will start with the project introduction, then I will go through the Tampa Bay's critical infrastructure, then some decadal changes from 2002 on till 2022, explaining some demographics, some land use and cover, some vulnerability changes, and then I will go towards the observe storm surge and king tide's impacts to critical infrastructure. And after that, I will go through the sea level analysis and contributing factors. Then I will provide some mapping information about the future conditions, and I will conclude with the impacts of these hazards to the Tampa Bay's area critical infrastructure. So for the pre-introduction, the objective of this project is to understand the current and future impact of sea level rise and storm surge to Tampa Bay's critical infrastructure. The area of the analysis is focused on the Hillsborough and Pinellas County, and the methodology was both quantitative and qualitative. The quantitative analysis was based on the water level and demographic data analysis, while the qualitative analysis was more on the land cover, the bathymetry information, and some vulnerability data. Some of the tools used was MATLAB as a statistical software, and then ArcGIS Pro of the Geographic Information System software, or the mapping tool for this analysis. The data source used include USGS, NOAA, Tampa Bay, Regional Planning Council, the Pinellas and Hillsborough County Open GIS data, SONEL, Census, and CDC. Okay, so now talking about Tampa Bay critical infrastructure. Any critical infrastructure are those assets considered essential for the safety and for the benefit of the society. And this could include hospital, fire station, airports, shelters, government buildings, military base, many others such as park, wetland areas, and sometimes those include utilities um, among another systems that provide services for the society. In this case, I am focusing on the one listed. So hospital, fire stations, airports, shelters, government buildings, and military base. And then we'll jump to the decadal local changes. Understanding the decadal demographical land cover and vulnerability changes to the Tampa Bay area allows a more comprehensive analysis of the sea level rise and storm surge effects to the society. Talking about demographics, I will explore population growth, change in age dynamics, and economic expansion. When I discuss land cover, I will touch base on the expansion of developed areas and impacts to environmental areas. Then the vulnerability, I will focus on the rising socioeconomic disparities and more susceptibility factors. Talking about demographics, population growth in both Hillsborough County and Pinellas County combined have a 27.1% of population growth from 1.93 million in 2002 to 2.49 million in 2022. This was driven largely by Hillsborough urban expansion, younger demographic influx. Instead of age dynamics, the region saw a rising senior population, with 27% of the Pinellas resident age 65 plus compared to 15.4% in Hillsborough. So Pinellas have a greater median age than Hillsborough. So Pinellas have 48.8 years and Hillsborough have 37.6 years. In the figure number two, we can see the Tampa Bay area population over time. So we can see exponential uh, increase of population. Talking about land cover, we can see that urban and build-up have been increasing since 1974, when it began at 15% of the total area and now takes up to 38% of the total area. In terms of upland forests, these have been mostly the same for the entire study period. However, it's important to note that we saw some um, percentage decrease in the years of 2004, 2020, 2014, and 2017. Well, we see those numbers get back to normal in 2020. Talking about water, we see that the water dropped from 30% to 12% since 2017 to 2020. So this is a number that is really concerning in terms of land cover changes. Now, talking about the overall social vulnerability index, we can see here that the Pinellas County have changed from low to medium vulnerability index, and then went through an area of low vulnerability index, and then went to uh, a low to medium social vulnerability index. Well, um, Hillsborough County have maintained a medium social vulnerability index. When when the social vulnerability index is low, is that the population is prepared, is well, is have low socioeconomic disparities, and when um, the the social vulnerability index is high or medium high, is when we can observe socioeconomic disparities. So Pinellas County improved and then went back to that low to medium category. These are some observed storm surge and king tide impacts. The figure 3, we can see the Tampa General Hospital during the Hurricane Elaine, and then figure 4 is a flood road during a king tide flooding event. And now going through the sea level analysis and contributing factors, uh, there were three different stages used or data collected for this analysis, all coming from NOAA Tyson Currency Station. The period of time gathered was from 2002 to 2022. The hourly water level and meteorology data, and also the USGS digital elevation models, and the sunlit vertical motion data. So this is the water level data in Spirit Station. This is the main one that we are using to display the analysis complete as part of this project. Um, and then we can see the annual maximum in St. Petersburg Station um, with the D trend line as well. If we go back to it, to figure A, we jump to figure A when then we have the water level return periods in St. Petersburg Station. Um, and then going through the contributing factors of sea level rise, we can see that the DM change experience improve in it gained some elevation, while the vertical land motion data provides us that we can see a negative trend in vertical motion with a negative 0.072 inches through 18 years of data in the MacDill Air Force Base Station, and you have a rate of 0.006 inches per year of subsidence. Um, then I will be showing some of the sea level rise projections and some sort of projections. I will be showing the sea level rise 2040 and 2017, 2070 intermediate high scenarios for Pinellas County and Hillsborough. And I will be showing the storm surge category 3 and 5 maximum envelope of water, which is the worst case scenario for storm surge, um, showing the Tampa Bay Regional Planning Council stand. So here we can see that the sea level rise intermediate height 2040 scenario doesn't uh, extend too much into the land. We can see definitely that in the 2071 we can observe more some part of the land affected by the sea level rise. And then talking about the some source category 3, we can see that it affects most of the Pinellas County and most of the coastal Hillsborough County. This intensifies with the category 5 hurricane. As you can see here, almost all the areas are covered by uh, the storm surge. Now talking about the impacts, sea level rise and storm surge. Sea level rise direct impacts airports, military base, and one essential government building. When we intercept 1 kilometer from the direct impact, we can see that 5 hospitals at least are affected, 20 fire stations are affected, and 2 airports are affected. And now consider the storm surge, 45% of the critical assets are affected. And to conclude, there are three key takeaways from this term project. Number one is the increased risk to critical infrastructure. Uh, we need to project sea level rise and storm surge impacts, exposing critical assets like hospitals, government buildings, and utilities to frequent flooding and damage. Vulnerable assets are often located in low-lying, high-risk zone near the coast, so we need to provide some changes to adapt to this situation. And then compounding economic and social impacts, the damage to essential infrastructure, public services, healthcare delivery, and emergency response, leading to cascading effect of on local communities. And also this property impact of unserved populations amplify existing inequalities. So that's why it's important to take into account the social variability in this analysis. And then data-driven insights, mapping and analysis reveal hotspots where critical assets face the highest exposure, enabling target mitigation and resilience planning. And then we have to take a look of past events like king tides or hurricanes, demonstrate the need for adaptive infrastructure designs. Thank you very much. I hope you liked the presentation.